NCBM 0324, Section 1.1, Order of Operations, Part 2. So going off of our last examples, remember we're doing PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. So let's look at how complicated these might get. Let's try example E. We have negative, parentheses, 3 minus 5, minus a square bracket, 2 minus parentheses, 3 squared, minus 13, close parentheses, close bracket. So in this case, thinking about parentheses, exponents, multiplication, division, addition, subtraction, I have parentheses kind of in a lot of places. I see them at the beginning, I see them here, and I also see these square brackets that are going to act the same as parentheses. But like any other problem, we're still going to apply those operations inside of the parentheses first. So let's start on the first set that we see. Over here we have 3 minus 5. Notice that that minus is outside of the parentheses. So I'm going to keep that minus with whatever answer we get from the operation inside. We're still going to have to apply it. And I'm going to have 3 minus 5. Well, that's negative 2. Now you notice here, I do keep my parentheses because I have a minus in my answer from the inside, and I also have that minus from the outside. So to keep track of them, I'm going to use my parentheses to denote that this value that I found came out to be negative. So that's something to keep in mind, right? Keep track of all our signs. They're so important and they're easy to get mixed up. Then I'm going to go to my next part of my expression here. I'll deal with the brackets in a little bit. Let's simplify the innermost parentheses in this case. And inside these parentheses, I notice I have an exponent. So I'm going to do that exponent before I do subtraction, because exponents come before subtraction. So 3 squared, 3 times 3 is 9, minus the 13. Now it's looking a little cleaner. I'll do this inner parentheses in my next calculation. Keeping everything else, we'll deal with it in a little bit. And 9 minus 13 gives me a negative 4. Again, I still keep the parentheses because my value came out to be negative, keeping track of my signs. Now let's see about those brackets. So I have my front value, and here I'm going to have 2 minus negative 4. Well, I know when I subtract a negative number, that's like saying add them, and 2 plus 4 would end up giving me 6. So all of this inside of my square brackets here, all simplified down to a 6. And let's look at our first value now. Let's simplify this, right? So we did parentheses, there was an exponent involved. Now here technically I have a multiplication because I have that negative, think of it if you need to, as a negative 1 in front. But I have a negative times a negative 2. So that turns out to be a positive 2. Drag along the minus 6. See, this minus has been kept going. And we don't have any more multiplication, division, addition, subtraction. We do have a subtraction. And 2 minus 6 gives us our final answer of negative 4. So within more parentheses, within these square brackets, we still follow the same rules, right? Always parentheses, exponents, multiplication, division, addition, subtraction. Let's see some with a fraction. Let's look at part G. In part G, we see a lot of parentheses flying around here. We see this fraction that we may start to maybe feel a little anxious about when we see it. But think of this fraction as a big division, right? That's another way of thinking about a fraction, is if we're dividing that numerator by that bottom part, that denominator. Whatever we feel about it, we still have to follow our order of operations. So let's get started. we see parentheses, right? I'm looking at this parentheses first, the 3 minus the 7. Right? That operation needs to happen before anything else here. So I'm going to go ahead and write this, a big fraction still. 2 is in the front. 3 minus 7 gives me negative 4. 4 times this 8. 4 times this negative 3. Negative 3 times this negative 2. Looking a little nicer. Now, the rest of the parentheses. Right? Let's think about how the rest of the parentheses are being used. Inside each of these parentheses is a single value. So those have already been simplified down. Another way of illustrating multiplication is by writing these parentheses in this way. So what we're really saying here in each of these cases is we're multiplying those two numbers. So in parentheses, used to enclose more operations, sometimes used for multiplication, which can get a little tricky, but just think about it as, do I have a single value versus is there more going on inside, right? Then we can go the other way. We don't see any exponents, so I don't have to worry about that, but I do again have all those multiplications. So let's go ahead and apply those multiplications. I'm going to do 2 times negative 4, well, that's negative 8, plus, we can maybe do these all at once, 4 times 8 is 32. 4 times negative 3 is a negative 12, plus negative 3 times negative 2, well, negative times a negative is positive, 3 times 2 is 6. Again, each step, making it look nicer, making it look a little bit more manageable, right? It's not so cluttered, you might say. Let's go with our next operations. We got to do addition, subtraction next. And I say that and not our division because division, we want a single value on top and a single value on the bottom. So we're going to do the addition, subtraction next. So I have both additions here. Let's check on the numerator. Negative 8 plus 32. That gives me 24. Negative 12 plus 6. Well, that's a negative 6 since the 12 has the minus sign on it, the negative sign. And now that we have single values, now we can go back and do the division. And we needed to simplify the numerator, simplify the denominator. It's almost like parentheses. We got to make sure those operations are applied first. In this case, in this particular case, 24 divided by negative 6 then gives me negative 4. So the problem started pretty complicated, it looked pretty messy. All of these numbers mixed in there, and it finally came out to a negative 4. Let's try one more with the fraction. Let's try h. We have 12 plus 9 times 7 minus 2, all divided by 4 squared minus 48 divided by 3. All right, order of operations, we do parentheses first. So I'm going to copy down quite a bit of this while we get our parentheses cleared up. We have in our parentheses 7 minus 2. Well, that's a 5. I can keep the parentheses there to act now as multiplication. Then on the bottom we have the 4 squared minus the 48 divided by the 3. Keeping this going. Parentheses are good. This is going to be a multiplication. Maybe I'll write to remind myself. We did parentheses. We have an exponent next, this 4 squared. Let's do that. All right, 4 squared is 16. And we still have minus 48 divided by 3. That's okay. So it looks like our exponents are done. Now we go to multiplication, division. I have one of each. Multiplication up top, division on the bottom. And I think we're feeling pretty good. I think we can do those at the same time. We have 12 plus, okay, 9 times 5 is 45. We have the 16 minus, let's see, 48 divided by 3. Well, that gives me a 16. All right. Multiplication, division, done and done. Now we go to addition, subtraction. Right? Addition on top, subtraction on the bottom, and then we'll go back and do one more division. So maybe I shouldn't delete that. Shouldn't check that yet. All right, let's see what we get up top. 12 plus 45 gives me a 57. 16 minus 16 gives me a 0. If I were to try this in my calculator, what would my calculator tell me? In fact, if you want to, try that in your calculator. Well, it turns out this is going to give us an undefined answer. Undefined, there we go. And that's because we can never divide by 0. Right? That's our golden rule in math. We can never divide by 0. So our answer in this case, the expression is undefined, right? It doesn't exist because of that 0 in the denominator. Can I have a 0 on top? I could, but just not in my denominator below.